Now, one thing I don't want us to forget about are proofs. Last semester we were talking about proofs. We learn about them, but I don't want us to forget. So let me do a couple of proofs right here. Questions 13 and 14. I want to do a couple of proofs. So for 13, it says complete the proof showing that the triangles PFH and triangle GQE are similar. So I see two triangles on my image. So PFH and triangle GQE. I want to prove they are similar. Okay. For similarity, one thing I want to remember, triangles are similar. There are a couple rules that I know. Side, side, side. I also know side, and angle, angle. Okay. So for similarity, the angles have to be equal. That's one thing I got to remember. Angles have to be equal and sides have to be proportional. So let's see. It says, note, the diagram is not to scale. Okay, so what that means is don't grab a compass and start measuring corners because it might be a little bit off. Okay, it's for when it says not to scale, the number that is given, we're going to accept it. We're going to say, yep, that's the measurement. I'm not going to verify it. I just accept it. Okay, so one thing, I'm looking at my angles and I see on my angle on the left, I have 40 degrees. On my angles, on my the two angles on the triangle on the right, I see 75, 65, but I don't see 40 degrees. However, one thing I remembered is I can solve for the measurement of one angle as long as I know two. So what I'm looking at this triangle, the one on the right. I see two angles. So what I'm going to do is for me to find the third angle, I'm gonna go 180 minus the two angles given, right? So let me just say my step number one. Let me say my measurement of angle. So I'm looking at this angle. Okay, so I remember I have to use all three letters. In this case, G in the center. So I'm going to say the measurement of angle QGE is equal to 180 minus measurement of angle GQE minus the measurement of angle GEQ. And you're like, well, how is that in numbers, Mr. Dunn? So, well, 180 minus 75 minus 65. Well, what's that? What's 180 minus 75 minus 65? I use a calculator and I happen to get 40. Okay. So I just say this angle right here, it is 40 degrees. Okay, I have to give a reason. I have to give a reason why I did that. All right, that's what we do in proofs. We do something, but then we got to give a reason on why. Usually we name a rule, and then the rule that I just used is called angle sum theorem. Theorem is the fancy way for a rule. Right, the angles of a triangle add up to 180. So one angle must be 180 minus the other two angles. Okay, cool. Interesting that I have 40-degree angles on both. So I'm gonna say my step number two, I'm gonna say my angle FPH is congruent to my angle QGE. I was just basically saying this 40-degree angle is congruent to that 40-degree angle. Well, how do I know that? My rule I'm going to use is definition of congruent angles. Definition of congruent angles. Basically, I just want to say those two angles are congruent. Why? Because for side angle side, I need the angles to be congruent and the sides to be proportional. Okay, so now I'm gonna do something here. I see on the triangle on the side, I have 5 and 5. So I have two measurements. So my step number 3, I wanna use those two sides. So PF and PH. I'm gonna use those two sides. And then I see here on the left, I see 10 and 10. So I'm gonna use those two sides as well. GQ, GE. Those two fractions are equal, right? 5 over 10 is equal to 5 over 10. So this is what we called ratio of similarity. Okay, so I have the two sides from one triangle are proportional to two sides of another triangle. I have the included angle on one triangle is equal to the included angle of the other triangle. So I think I'm ready to complete my statement here. I'm going to say triangle PFH. Oops, that's a forgot my F. So PFH is similar, no, not congruent, is similar to triangle GQE. That's what they wanted me to prove, right? Remember how at the beginning it says, prove that those two triangles are similar. I just said they're similar. How do I know they're similar? The rule that I'm going to use in this case is side angle side. Good. Let's take a look at another proof here. Complete the proof showing that the triangles FGS. Oh, which one's that triangle? This big triangle is, and then triangle FQE. That is this smaller triangle. Okay, so I highlight them in red and blue so we can see which two triangles I'm talking about. And it says prove that they are similar. Okay. Note the diagram is not to scale. And then to finish this, it says find the length of GS. Oh, I want to find this length. Okay, so a couple things I'm gonna do. I'm gonna say first I need to show that they're similar, and I gotta remember my rules for similarity are side side side, side angle side, or angle angle. From the red triangle, I don't know this side and I don't know this side. So there's two sides I don't know from the red triangle. So I'm not gonna try to use a rule that has sides. Instead, I'm gonna try to go for angle angle. Okay. So two angles of the small triangle are equal to two angles of the big triangle. Okay. First of all, I see this corner. Corner F, we can say it's used by both triangles, right? The little triangle and the big triangle are using it. So let me use that rule. Let me use this. I'm gonna say angle QFE is congruent. Remember QFE, that's that angle from the small triangle. Is congruent to angle GFS. Basically the same corner from the big triangle. When you use that one side it's equal to itself, or in this case, one angle is equal to itself, the rule that we call that is reflexive property. So let me write this, reflexive property. Okay, So I just said this angle, this corner right here, they're both using it, so I'm gonna use it. Okay, another rule that I'm going to use, let me change this to blue so we don't get confused. Because I see 90-degree angles. I see this angle's 90 and I see this angle's 90. So they're both 90-degree angles. So I'm gonna say angle FQE is congruent to angle FGS. And then I'm gonna call this the right angle theorem. Basically, if one angle is 90, it's a right angle, then the other is a right angle. They have to be equal. Okay, good. So now I have two angles from the small triangle are equal to two angles on the big triangle. So I think I'm ready to prove. I'm going to use my step 3. I'm going to say triangle FGS. So the big triangle is similar to triangle FQE. And I'm saying this by angle. Okay, let me first, the thing I needed to prove that two triangles are similar. Good. Okay, I know for similar means the angles are the same and the sides are proportional. Once I said, once you say two triangles are similar, you're already saying that triangles, that means the sides are proportional. So let me complete this for, I'm looking for to find the length of GS. Let me, this side right here. One thing I'm going to do is I'm going to say, well, sides are proportional, right? So I'm just going to use my step number 4. Let me make two fractions. From the small triangle, let me use the sides FQ and the side QE. That's from the small triangle. From the big triangle, I'm going to use the side FG and then the side GS. And I'm going to say these two are equal. And I'm just going to say these sides, I want to call the ratio of similarity. Remember, the ratio of similarity is when you're using two sides from two figures that are similar, and then you're making fractions and letting them equal to each other. So let's see. Let me solve this. Let me do my fifth step. The side FQ, if you see, from F to Q is 4. The side from F to G, see, part of it is 4, the other part 16. I'm going to say the whole thing, FG, is 20. Now, QE, if you see QE, the distance QE is 6. And then the side GS, I have no idea what it is. I'm just going to call it GS. But it makes sense that I don't know because the question at the beginning was find the length of the segment GS. Good. So let me just say, okay, I did my ratio similarity. I replaced the values that I knew. Now I'm going to use cross multiplication. So that gives me 4 times the segment GS is equal to 120. My rule here, let me use cross multiplication. All right, just went 4 times GS. So that's what gave me 4 GS. It's equal to 20 times 6. And then let me divide both sides by 4. So I'm dividing the same thing on both sides. I'm dividing both sides by 4. So this thing, let me see, we're dividing. So let me call this division. I'm dividing on both sides. So when we do it on both sides, that is called uh, property of equality. Okay, so if I was adding the same thing on both sides, I would call it addition property of equality. If I'm subtracting the same thing, subtraction property of equality. In this case, division property of equality. So that gives me that GS, the segment GS is equal to 30. Oh, there you go. We solved it. Remember, it was find the length of the side GS. There we got it. Okay. So again, this is for us to not forget our proofs. Our homework, I'm not going to ask you guys for proofs, but remember, we do have interim tests. Those tests are given to me by the district. I don't make them. They might give you guys a proof. I don't know. They might not. I'm not saying they will, but I'm saying they might. So we need to remember how to do proofs. All right, for today's assignment, let me take a look at question numbers 15 and 16. We're going to be taking a look at this. Now we're going to be working with similar properties. So here is a triangle CED. So we're looking at the big triangle CED. So let me do red for that one. In the line segment XY parallel to ED. Okay, interesting. XY and ED are parallel. XY has a length of 4.05, which we can see it. It's 4.05. ED has a length of 6.4. If the triangle CXY has an area of 4, so I'm going to say my area is 4. So that's the small triangle. The area is 4. What is the area of the triangle CED? The area of the big triangle. Please note that the figure is not drawn to scale. Round your answers to 2 decimal places. Okay. So we're given by telling us these two sides are parallel, they're basically telling us these two angles are congruent. The angle XCY is congruent to the angle ECD. So the proof that we just did, the second proof that we just did, basically for us to know that those two triangles are similar. The small triangle, let me highlight it in yellow. The small triangle and the big triangle are similar. But now we're dealing with areas. Before I look at the question here, one thing I want us to do, let's imagine, let's review area, but let me review with a rectangle. Let me do, let's say I have a 5 by 3 rectangle. Okay, and then let's say I do a similar triangle. Everything here, my measurements 5 and 3, I'm gonna use a scale. I'm gonna multiply them by the same thing. I'm gonna make my numbers bigger. What if we multiply by 3? So 5 times 3 is 15, and 3 times 3 is 9. So my measurement here is 59. These things are similar. Because if I was to do fractions, 5 and 3, 5 goes with 15 and 3 goes with 9. If I was to do fractions, they do simplify to the same things. Okay, so these triangles are similar. But let me take a look at something about the area. On the small rectangle, 5 times 3, my area is 15. For my big rectangle, 15 times 9, my area is 135. So we're going to say, okay, here's my 15, my area of the small triangle. I'm gonna multiply this by something, and it has to equal the big area. So again, I have the small area multiplied by something equals the big area. Okay. I want us to check something real quick. Remember how our numbers for 5 to become 15, I multiplied it by 3. If I was to multiply it here by 3, 15 times 3 is not quite 135. Interesting though. What's the measurement that we know about area? Is like on our, if we have, let's say meters, is it just meters? Is it meters squared? Is it meters cubed? What's the exponent that we know on area? Think about it. Square. Okay, area is in square. So let me do my 3, my scale. My scale here, let me do it squared as well. Now, when I use a calculator, 15 times 3 squared. I gave you guys a calculator before on your canvas. So go, let me use that real quick. When I'm looking at our page, I see here on the left, I see calculator. So let me click on that. Want us to get familiarized with this calculator. So please do use it. So our question was, what's 15 times, where's my times here? And then 3 squared. So I'm going to click 3. And you see this a squared? Gives me a squared. Oh, 15 times 3 squared equals, I'm going to press enter so I'm done with the question. 15 times 3 squared equals 135. So let me come back to what we were working with. Okay, 15 times 3 squared equals 135. Now, one thing we're going to be doing, notice how the 15 was my small area. Let me write this in black so it makes more sense. The small area. 135 was the big area. My 3 squared is my scale squared. Okay. You guys might be like, what do you mean with scale? The corresponding sides. If I get 15, 5 and 15, all right, my scale is the big number divided by the small number. 15 divided by 5, that's my scale. I could have used the 9 and the 3 and I get the same scale. So the big number divided by the small number, that's our scale. Okay, so let's take a look at here. How am I going to work question number 15? My small area, remember I have to do small area times scale is equal to the big area. So my small area is 4. My scale, okay, I'm just going to go 6.4 divided by 4.05 squared. I don't need to figure out what's 6.4 divided by 4.05 right now. I don't need to know. I'm just writing my scale because that's probably going to give me a long decimal, and I don't want to deal with that. And this is going to be the big area, and that's what we're solving for, right? So that's really what I'm going to type. I'm going to grab up my calculator. I'm going to go 4 times 6.4 divided by 4.05 all squared. So let's go back to the calculator that I have. So let me go 4 times. Okay, so here, let me open up parentheses. And inside, I'm going to type the fraction. I'm going to type this fraction, 6.4. At the bottom, let me type in 4.05. I'm going to close my parentheses, and then I'm going to write square. So I'm looking at the screen, make sure this is what I want. So 4, the area of the small one times the ratio, the scale squared, and it tells me it's 9.988 and then some other numbers, right? So let me just copy the first 3 decimal numbers. So 9.988. 9.988. When I read the instructions, it says round your answer to 2 decimal places. I wrote 3. But I need to round it to 2. Okay, I wrote the third because I do keep an eye on the third numbered. If the third numbered is 5 or more, which is the case, it is big enough. So that's gonna push this number over. So my answer will be 9.99. Nice. Make sure you write 3 decimal numbers because you need to look at the third one to round it to 2 decimal places. Not bad, not bad. Let's take a look at here, question number 16. Here's a triangle CED and a line segment XY parallel to ED. XY divides CED into 2 shapes with area 1 is 14. So my area 1 is 14. Area 2 is 6. Oh, this is 6. Just the area 2. Just this area. Okay. Area 2, 6, XY has a length of 7.89. What is the length of the line segment ED? I need to solve for this side. I don't know how big it is, so I'm going to call it a letter. I'm going to call it X. Please note that the figure is not drawn to scale. Round your answer to 2 decimal places. Okay. So I'm going to say the small area is 14. My scale is X over 7.89 squared. This is equal to, hold on, the big area is this whole thing. So I'm going to say the big area is 20. Okay, because area 1 is 14, area 2 is 6. So 14 plus 6 gives me 20. The big triangle, the big area is 20, okay? So be careful. Be careful what information you're looking at, okay? Huh. What am I gonna do here? Because I have the X there. I want to kind of leave the X by itself. So let me divide both sides by 14. Let me change this to blue. So let me divide both sides by 14. So I get this. So I have that X over 7.89 squared is equal to 20 over 14. If I was to go 20 divided by 14, I'm pretty sure it's going to give me a long decimal. So I don't want to deal with it. So I'm just going to call it 20 over 14. Now, how am I going to undo a squared? I know multiplication, division undo each other. I know addition and subtraction, they undo each other. How do I undo an exponent? In this case, the way I'm going to undo a squared exponent, I'm going to undo it with the square root. A square root and square exponent cancel out. So let me use this side for space. So I have that X over 7.89 is equal to the square root of 20 over 14. I'm just trying to have X by itself, so whatever I get, I can type it on the calculator, not a big deal. Okay. I want to have X by itself, so let me multiply it. I'm going to change this to orange. Let me multiply both sides by 7.89. So I get that x is equal to, I'm gonna write my 7.89 first here. 7.89 times the square root of 20 over 14. Okay. Now that's not bad. I can type that in. I can type that in. That's why I said use that calculator that I gave you. It's easier. Okay, so I'm gonna press enter. So I go to a new question here. 7.89 times, I have a square root, and inside the square root I have a fraction. So and then inside the fraction was 20 over 14. Press enter. So just keep an eye, 7.89 times the square root of 20 over 14. Good. So I see what, 9.430. So I'm going to call that 9.43. Okay. Let me come back to where we're working here. X equals 9.43. Okay, that's all I wanted to work. So today, how are you guys, what are you guys expecting? Again, the proofs were just for us to remember how to do proofs. You guys are going to be looking at small area. Let me come back to our formula that we came out with earlier. Small area times the scale squared is equal to big area, the big triangle. And then the scale, remember, I divided two sides. I went the two corresponding sides. On question number 15, 6.4 divided by 4.05. Question number 16, it was x divided by 7.89. Okay, there you go.